live streaming, which is, it's working. So that's great. So live streaming is working. And I'm going to share my screen. And we'll give it just another minute. And then we'll start. Okay, welcome everyone to our first session of day 4. So we've made it to day 4. We're very pleased to have with us Yinlin Chen, Assistant Director, Virginia Tech, talking about streamlining DBpedia queries with natural language using large language models. We've been hearing a lot about large language model lately, so this promises to be a very interesting session. I'm going to go ahead and stop sharing my screen. Yinlin, take it away.
Hi, good morning. Let me share my screen. I just share my screen so everybody can see it. Okay, so let's start.
Yes, we can see it.
Great, thank you. Okay, so today topic is just talk about how to use GPT-4 and to interact with linked data and DBpedia. And see, you can see in here, I just very briefly introduced the linked data and the DBpedia and introduce about query language model, and then how to use GPT-4 to query DBpedia, like linked data repositories. And then I will do a demonstration and about how this works, and finally conclusions. So linked data, I believe everybody in here have a different level of knowledge. So I just very briefly introduce linked data. So it is a method for publish and interlink RDF data on the web. So they can to one source and get another source. Okay, so to the web, and they have to access to linked data. There are multiple ways, as you can see in here. You can use URIs and HTTP and the different kinds of protocols. And usually, most people use Spark query and to access linked data. And so you can use this because of linked data. You can like navigate pushing the data source, right? And all these things have meaning, so you can like see what kind of data you are looking for, and continue find another data. And also not just for users, and something like search engine can do this to call a semantic web. So it's a very useful protocol and method to share the data around the world. And DBpedia is the implement of linked data. Okay, so it basically contains all the data from the Wikipedia and transfer into linked data, so people can use this to find the informations. So because it's an implement in linked data, so usually you need to, as you can see in here, using this protocol to access this data in the DBpedias. And so usually how to find the data in the linked data, there are many. I just did 3 in here. Most common one, so you can use Spark, some linked data repository will provide a Spark endpoint. Okay, so you can use in the Spark queries. Okay, so yeah, so the thing is you need to understand how to write the Spark queries. And also there are libraries. Right? If you are a developer, you can like using these library and to program, okay, and using this protocol to access linked data. Okay, and also or you can use linked data APIs. Okay, they provide web service, and you can access linked data. For example, DBpedia, they have a Lookup API, so you can access the data. Okay, and they have many of them provide some kind of user interface, so you can issue some keyword and access the data. Okay, so this is one example. You using Spark, they provide Sparkle endpoint, so you can see there's a URI in here, and you need to like understand how to write this. Right? So this is 5 people who get a Nobel Prize in literature. Okay, and if you understand how to write this, and you can issue this to the endpoint, and you'll get a result. One way to do that using Sparkle queries. And as I say in the previous slide, so they provide a Lookup API, right? You can like, okay. But usually people want to ask like this. I just use this as example, right? And provide search just like you search your Googles. And you can see like this. It find a lot of information, but not actually answer the questions. Right? You better use this using a keyword. Okay, maybe get a better result, but this is how this works. Right? Otherwise, you need to understand how to translate these questions into a Sparkle queries in order to get more accurate result. Okay, but this is kind of how this works. Okay, so how about using the same question on the Google? Right, so this is a screenshot. So I just use the same question in here, and it will tell you answers, right? And this is an answer from the Wikipedia, right? In here. Okay, it will tell you what's the correct answer in here. Right? And the DBpedia contain all the information from the Wikipedia, right? So the idea is like, so if I can program this, right? So this is a Python program here, okay? And I run this Python program, right? Ask the same questions. And somehow this program understand this language and able to transfer this language into a Sparkle query, as you can see in here, right? The transfer language people usually ask, right? And become a Sparkle queries. And send this Sparkle query to the endpoint and return result. Okay, you can see in here. Then it match to the actually the answer in the Wikipedia in here. You can see in here in bold font in here, right? So you can see it's get the correct answer here. So the thing is how the machine or program to understand what people usually general people ask and able to translate natural language into the Sparkle query and finally get the answer. So this is the main idea of these presentations. Okay. So in order for the machine to understand our language, like English in here, so actually it's called a natural language processing, right? So we lay out a lot of algorithms or programs, right, or machine like this. You can see many examples in here. We continue build a machine or agents, right, to understand human language. Right, we want the program or machine to learn a language, learn how we interpret, know what we are talking about. So the machine can understand how we use the language and understand how we ask, and then can provide better answer. Okay? So it's kind of a natural language processing. Okay, so this called NLP in here. Okay, so NLP have a lot of tests. This is all an example of NLP test. And the last one is like question answering. So like we just simply answer the questions, and they can provide the correct result in answer to us. It's what we are looking for. Okay, not many people understand how to write a program or understand how to write a Sparkle query. Okay? Right. So basically, it's better just the machine understand what we are and they give us the answer. So language model, there are a lot, right? I believe everybody know the ChatGPT, right? ChatGPT is a language model, okay? So language model is simply just AI models, right? AI is just like people, machine, like they can think, for example, okay? So they can actually we use build the AI models, okay? They can predict, okay? Like based on the input and predict output. And most we use this because it's a language model. We want to like they understand what we are trying to ask and predict the answer. And how we build this? Generally, we use a lot of test data. We want because it is a language, right? So we give a machine a lot of samples based on the sample data point, and based on this test, okay, and they can learn how to predict next word. Okay, so like in here, so there's a language input, there's a text input, right? And this is a test output. Okay, this is returned by the machine. Okay, actually each character in here is predict. Okay, so just like predict select S and the next E and the next L and then continue. Okay, so how the machine works is just like predict next character, predict correct each character one by one until it finish the predictions. Okay? So this is how language model works. Okay? We use a lot of tests, okay, and build the language model to predict next word in a sentence. Okay. Okay. So once we build language model, there are many different kinds, and the ChatGPT is one kind. Okay, one kind, and we also call it the foundation models, so it can handle different kind of tests, and so it can because it can handle different kind of tests. Okay, so we can integrate into many applications. So you can see like chatbot or content creation, machine translation. Okay, translate English to another language, or semantic analyze. Okay, to see this sentence is a positive or negative. All right, so this presentation also present integration to use the language model to perform some kind of test. Okay, it's one of the applications. And so there are many applications. So like ChatGPT is based on GPT-3 and the GPT-4. Okay, it's created by OpenAI, and Google have BERT, and I believe Microsoft and Facebook have their own. There are many language models. And so this you can see here they have training. We use a lot of tests. So there's a large language model, huge. They can have gigabytes of test data, okay, to train these language models. Okay. And there are many kinds. So I just these 4 kinds in here are relevant to this presentation. So first is a prompt based. So we provide input, a prompt, and want the machine to able to answer the questions. Okay. So it's the initial input that generate continuations, okay, generate answers. Okay. And the second is the zero shot. So you can see here, I didn't train the model, I used the models. Okay, use the model already trained by OpenAI. I use a GPT-4 in here. Okay, so I didn't do any training, I just used this. Okay, and based on these foundation models, so he just like perform this test and do the work. So right now I just ask this GPT-4 to transfer human language into the Sparkle queries. And then there are also other kinds. So if sometimes zero shot doesn't work, so we need to like do some instructions, okay, to guide this language model to answer the question we are looking for. Okay, so there's a few shot promotion, prompt. And another is charging tuning. So this is more complicated. It's just like we try to like modify language are being built. Okay, they have some kind of behavior being trained. and based on instructions, and they can do the things or just guide them in order to produce the result we want. But today we just we only use a prompt and base a little shot, able to perform a task to transform the natural language into the Sparkle queries, right? Because Golang is pretty much straightforward task for these large language models. Okay? So these are very general examples. I just asked, okay, to the GPT. Okay, backend is a GPT-4. Okay? So I just simply ask this, and he will return this Sparkle query and with some explanations. This is what he do is a output, right? So he will tell you, okay, based on this input and some explanations, and then create Sparkle queries, and then you can get a result. Okay, so and once I see this work, right, so I can write a program to make this work more generalized, to create a service based on this. So you can user want to query DBpedia, they can just answer general questions, okay? And use large language model to create a Sparkle query, okay, like in here, and of course then issue to the endpoint and get a result, as we can see in here. Okay. So let's demo it. So I just simply write a program, okay, and and I prepare some questions. So like this is just like I simply some kind of question here and just ask. Okay. And I test two models for user to choose. Okay. So default is GPT-4 because it's more powerful. Okay. And the second one is GPT-3, so it's more cheaper. Okay. Okay. So default is one. So GPT-4, and it just generates Sparkle queries. Okay. And search the DBpedia and get a result. Okay, so this one example, and I can choose the model. So it's the same questions. Okay, and so right now I select GPT 3.5, and I can still get a result. Okay, both good. Okay, so let's see. So let me ask this one. So which means I just simply create a program, and like the user can ask any kind of question as long as there's the data in the DBpedia, so the program can answer it. So that's another question. So you can see just translate the natural language into Spark query and get another result. And let me do the same thing, like you see if GPT-3 can get an answer or not. Okay, okay, still that's good. Okay, let me try again. Oh, another one. 0.5. Okay, so you can see both is good, and people. But this result more get more results, so that you can see the result different between different models. And let's see if how about this one? Who is let's step high. So this last one, and so first GPT-4. So there you get an answer, and this. Okay, so you can see this both GPT-3 and 4 can get an answer, just generate a Spark query very quickly and successfully. Okay, all right. So So based on my experience, sometimes GPT-3 will create incorrect result, but the GPT-4 is more powerful. Okay, but because it's more expensive, so you can see in here. So it's just like the cost is 20 times higher. So you can see using GPT-4, this is the cost. Okay, so GPT-3 only this small. Okay, and the same as output, it's most expensive. Okay, 30 times higher than GPT-3. Okay, so depending on your use case, okay, you can need to control the cost. And based on my task, okay, GPT-4 can produce more correct Sparkle query. Okay, so there are some considerations and limitations. Okay, so of course, in some case, okay, they are unable to create correct, or the Sparkle query, the sentence is very clearly is wrong. Okay, so you are unable to send the query to the Sparkle endpoint. You will just receive error message. Okay, and also usually you can see in here. So usually GPT will with explanations, right? But it will contain all these, okay, with a sentence and text. Then it is not the Sparkle query, okay? So you need to handle that. All right, and then the temperature. This is something. Let me just see the code, okay? So yeah, so there's two things. Okay, so one is I want to the model always answer the same return the same answers. So I set the temperature into 0. Okay, so it will not change. So if it's not 0, then the answer may be different. Okay, and also you can see I also tell them without explanations. So I will make sure I always get the Sparkle queries.
Yeah,
So
sorry.
yeah, okay.
Just a quick,
Right.
yeah, just
Yeah.
I think we're almost done, but I just wanted to ask if you could maybe increase the volume on your headset
Oh,
or something, just a little bit.
okay. Sorry. Yeah. Okay.
Okay,
So
sorry. Thank you.
but let's see it. Yeah. So the last one is just like because it's not free, right? So you need to consider the cost. Okay? But you can based on the rate and the traffic, you can estimate how much cost your service will be. So you can see 1K token, 1K tokens about 3 cents. Okay, got it. Okay, let's see it. Yeah. So thank you for joining us today, and just feel free to ask any questions. Okay, thank you.
Yeah, sorry to interrupt right at the end. So that was very interesting. Thank you for sharing that. We do have a few questions, and I'll encourage people to ask more. I see some typing happening, so I hope that's more questions coming in. So one question that I had was, it was just interesting to see for the examples you showed with GPT 3.5 and then comparing that to GPT 4. In your demonstration, the ones that you use GPT-4, the answers or the Sparkle query that resulted used prefixes, so it used like prefixes for the namespaces, whereas the one for GPT 3.5 used the fully qualified URI for each of the entities, and they're both correct. But I was just wondering if you know why that difference seems to be happening, or if that's normal. That's what normally happens.
So that's normal. So sometimes you will see the difference between two models because they are just two different models. Yeah. So now, yeah, this is normal. Yeah. And so sometimes you need to update your program to guide this answer into the way you want. So for example, if you want the answer all with a qualified name, so you can add the program to make sure you will return with a style query with all qualified names, something like that. Yeah.
Oh, okay. So there's, yeah, I was just wondering if there was a difference between how GPT 3.5 it analyzes the language. It seemed to be returning fully qualified URIs as opposed to the other one. But you're saying that either of those will happen, and what the program, like a script you wrote, can do is make sure that the result uses whatever format the user wants. Is that what you were saying?
Yeah. Yes.
Okay.
Yes.
All right. We have another question. Thanks to Yunlin for sharing. Have you tested this on other sources besides DBpedia? Also, I'm wondering what the role of schema documentation is for both learners of Sparkle and for users checking the correctness of the large language models query. So I can say the two parts separately. Let's start with the first one. Have you tested this on other sources besides DBpedia?
Don't, but I think you will, because it's Sparkle queries, right? So I think it will work. But you can test. Yeah, I didn't test. I just use the DBpedia because it's more reliable and more data I can present in here. Yeah, but I can test other sources after this meeting. Yeah.
Okay. And the second part of the question was, what is the role of schema documentation for both learners of Sparkle and for users checking the correctness of the query, especially when it starts to hallucinate?
So let me see how the way you can usually the ways you can see in this slide, right? So usually we will, before we release this service to public, so we can just test each one and compare check the GPT-4 able to produce the correct Sparkle query, and we can need to check the sentence and to make sure the output is consistent with what we want. Okay, you need to do that part. This part, yeah, usually you need to do that part. Yeah, in order to provide a better service. Yeah, you cannot skip that. Yeah.
Yeah, and the follow-up to that is they're wondering how it would work on a smaller linked data set that doesn't have as big of a footprint on the internet. So you're using DBpedia, which is very large, and I'm not sure whether you're using ChatGPT out of the box or whether you trained it on DBpedia. So I think that's maybe what part of the question's asking is, if you were, instead of DBpedia, if you were using a smaller linked data set, do you think it could generate queries in the same way?
The point is,
right.
Yes, sure. So the point is, I want this program to able to understand human language, right? So so you can see I can change to others, right? So as long as there's other Sparkle endpoint, I can test that. I just switch that. Because the point of this program is change the language into Sparkle queries. And I didn't train it, as I say, it's a video shot. Okay, I just change the models. Okay, you can see in here, I just ask what kind of models and just two models to select. I don't need to train, so I just handle that.
Okay.
And I forgot to demo one thing. So it's just not like English. So you can see if this one, so this service, so this is English. So actually we can using the or translate. So let's see if we just Spanish. So just like another one. So because it's large language model, they already oh wait. And still do the work. So you still transfer into the Sparkle query you can see here and get the answers. So even I can translate into Japanese because this is how this large they've been trained a lot of millions of data. So if I change to Japanese and
pretty cool.
So he still can interpret. Okay, he understands human language. Okay, and still got this. And you can see in my program, I didn't do any of the machine translation. I just used the models, and just like under 15 line of code, and I can finish that. Right. So once you update the programs, this one can like service can any kind of language they can answer that. Yeah.
Yeah,
Alright.
there was another comment about, I think, similar about being able to use this with Wikidata. I think your script right now, like you said, is using the zero-shot method, which means that you're not actually training on either DBpedia or Wikidata, but you're just seeing if you can generate a Sparkle query. So that would be, I think, a good way to start exploring. And then maybe if you can in Slack, talk to people about how they might go from there if they wanted to train on a particular data set, what kind of mechanisms and methods they would use. There's definitely interest there. So we are at time. Thank you so much, Yinlin. We'll continue the discussion on Slack, and it's time to go to the next.